Hello everyone, in this video I explain the power rule for integration. So we know that if we have to take the integral of x raised to power n dx, so this is essentially a power function. So what we do is we increase the power by 1 and divide by the new power plus c, and provided n should not be equals to -1. So this is what we already know. But we can extend the same formula for the powers of other functions when we don't really have x, but we have some other function in place of x. So the general power rule is, so if u is any function fx, so integral of u raised to power n du is equal to, so you increase the power of u by 1 and divide by the same new power plus c, and n should not be equal to -1 because the denominator cannot be equal to 0. So let's rewrite this function in other form. So let's plug in. So u is equal to fx. So let's do this substitution. So we know that we need to figure out du when we use the substitution rule. So du would be f prime x dx. So if this is confusing, you can think this of as taking derivative on both sides. So du over dx is equal to f prime x, and then du is equal to f prime x dx. So I'm going to do this substitution in our given form. So right now we have un du is equal to u raised to power n plus 1 plus c. So when I do the substitution, so I get, so in place of u, I'm going to write fx. So fx raised to power n du. So what should we do in terms of du? So we just figured out that du is equal to f prime x dx. So let's plug in that value. So f prime x dx in place of du, we write this. And then it means our formula should be, so this should be equal to fx. So simply increase the power of the function by 1 divided by n plus 1 plus c. So whenever you see this form where you have power of a function and the differential of the function. So we have power of a function and we have the differential of the function. We can simply increase the power of the function by 1 and divide by the new power plus c. So if you recognize this form, you can directly do your questions in one step. Thus, this is our new alternate form. So let's try to solve some examples. So we'll start with this example here. So we are given integral of sine cube x cos x dx. So I'm just going to rewrite this function. So what we have here is sine x integral of cube of that function times cos x dx. So there are two ways you can do this problem. One is a longer method, another is a shorter method. So the first we will do with the shorter method. So if we compare this with what I already did here, so what we have here is we have power 3 of a function. So this is our function power 3, and derivative of sine x is cosine x, and if you have dx with it, so this is the differential of the function. So it means in this case we should simply raise the power of the function by 4, so sine raised to power 4x over 4 plus c. So that is your solution. Or you can do the same problem by writing all the steps that you need use for substitution. So for example, if you start with, so other way of doing this problem is if you start with the problem. So we know that here we have inside function is sine x and the outside function is the power function. So we plug inside function. So let inside function is u. So we write du over dx would be cos x b cos x dx is equal to du. And then we plug in this value in our function. So we get the new function becomes u cube. And in place of cos x dx, we're going to write du. And we know that using the power rule, we increase the power by 1 and we divide by the same new power plus c. And the last step is we plug back the value in terms of original variable. So u is sine x, so sine raised to power 4x over 4 plus c. So you can use any method that you want. So either recognize the form by using this alternate form or do the proper substitution method. Let's take a look at the next problem. So here we have a function. So this is our function. And we have, so derivative of x cubed is 3x, derivative of 7x is 7. So we have the differential of the function. Differential of the function. And we have a 5 here. So we can rewrite this problem as, so take the constant outside and you have x cubed plus 7x raised to power 4 and you have 3x plus 7 dx. So if you plug in, you can use the substitution rule. So you can plug in u is equal to x cubed plus 7x and then you figure out the value of du, which would be essentially in this case 3x plus 7 dx. And with the alternate form that we just discussed, we know that we simply raise the function to 1 power more. So in this case 5 as it is, and we raise the function to 1 power more and divide by that new power plus with x cubed plus 7x raised to power 5 plus c, which is our solution. Let's do some more practice problems for the power rule. So let's take a look at this one. So we have, I'm just going to rewrite this. So we have integral of 2 1 plus tangent theta and the power is 1 by 2 secant square theta d theta. So again we have power of a function and we recognize that if I take the derivative of 1 plus tangent theta, so that is secant square, 1 plus tangent x, if I'm taking with respect to x, so it's secant square x. So this means here we have a function raised to some power and we have the differential of function. So we can apply our power rule. So in this case, so 2 is just a constant outside. So we have integral of 1 plus tangent theta raised to power half secant square theta d theta. So we simply raise the power of function by 1. So 1 plus tangent theta, the new power is going to be 3 by 2 divided by 3 by 2 plus c. So overall we get 4 over 3, 1 plus tangent theta raised to power 3 over 2 plus c. So in the next example, I'm just going to rewrite it again. So we have ln x over x dx. So again, we know how ln x and 1 over x are related. So I'm just going to rewrite this as ln x 1 over x dx. So ln x is our function and 1 over x dx is the derivative of the differential of the function ln x. So differential of function. So using the power rule, the solution should be, so raise the power of the function by 1. So ln x square over and ln x raised to power 2 over 2 plus c. Or if you prefer, you can rewrite this as 1 over 2 ln square x plus c. Let's take a look at the next problem. Upper limit minus lower limit. So plug in the limit. So we get sine inverse 0.5 square of that divided by 2 minus 0 square over 2, which is just 0. So we got pi over 6, which is inverse of sine inverse 0.5. So pi over 6 square over 2 minus 0. So overall we got, so 36 times 2 is 72. So we got pi square over 72 as our answer. So in the next example, we need to find the first quadrant area bounded by y and when x is equal to 1.5. So in this case, we are interested in finding this area. So only in the first quadrant. So we'll start from here and we're going to figure out this shaded area. So we're going to figure out this area that is under the curve above the x-axis and between x equal to 0 to x equals to 1.5. So the required area can be found by integral of this function y, which is e raised to power 2x over square root of e raised to power 2x plus 1 dx, and the limits will be from 0 to 1.5. So again, we notice that we have something in the denominator. So I'm just going to rewrite this function so that we can see this as a power function. So now we look at this function. So we have e raised to power 2x plus 1 raised to power negative half e raised to power 2x dx. And one thing we know about the exponential function is that derivative of exponential function is the exponential function itself. So in this case, and we also know that the derivative of 1 is 0. So essentially we can see that we have something like function inside and we can make the derivative of function outside 2x times 2. So in order to make this derivative here, so we can just multiply by 2 and divide by 2. So now we got the desired form. So we got a function raised to some power and we got the differential of the function. So it means we can use the power rule. So we can, so 1 over 2 is outside, we can increase the power of the function by 1 and divide with that new power, and we're gonna evaluate it from 0 to 1.5. Here 1 over 2 and 1 over 2 get cancelled. So now we're just gonna put the upper limit and lower limit and evaluate the integral. So putting the upper limit and lower limit, we get e raised to power 3 plus 1 raised to power half, and we got 1. So e raised to power 0 is 1 plus 1 raised to power half. So in the end, we got square root of e cubed plus 1 minus square root of 2. So if you want your answer in the decimal form, so it would be 3.178. So thanks for watching this video, and I hope you enjoyed it.